Hi guys, welcome back to video notes. If you are listening to this, that means you just recently finished or took an exam, right? Okay, so we're starting 5.6 today. The title of this unit is called Logarithmic and Exponential Equations. So recall, this means it's a review for us. That means we should have known what it is supposed to be. Okay, y equals log base a. Let me zoom in really quickly. Y equals log base a of x is equivalent to a to the y power equals x. Okay, keep in mind that this is the inverse. Okay, this is the inverse of my exponential equation. Keep in mind that, hey, a, this is your base, okay, has to be greater than 0, but never ever 1. So the base can never be 1 and is always positive. So that's what it's saying. If log base a of m is identical to log base a of n, okay, because the bases are exactly the same, then m must be identical to n, okay? So what we are trying to say is because log is a one-to-one function, if they are identical, we can drop it, okay? And it's still identical. Where m and n and base a are positive and is never, ever, ever 1. That means I cannot have a base of 1. If, this is really blurry, so let me just zoom in. Okay. If a to the u is equal to a to the v, just like what we have already studied, again, exponential function, it's 1 to 1, so we can drop your bases. Hence, u must be identical to v. So the common theme is, as you can tell, okay, is that if the bases are identical, whether it's in log function or exponential, you can drop them, so then the exponents are exactly the same. And again, a must be positive, the base must be positive, and it can never ever be 1. Okay? So with those reviews, let's look at our directions for example 1. Example 1. Solve expressed irrational answers in exact form and decimal rounded to 3 decimal places. Okay? Verify your results using graphing utility. So since I'm gonna need a calculator, let's have it out. And guys, if you are listening to this video notes, make sure you give yourself the time. Don't cheat yourself by being on your phone or being on your Facebook, whatever it is that you are on. Make sure you just dedicate this time for your notes, okay? If you're just doing something else, you're just cheating yourself, okay? So it says, hey, solve. Okay, first thing, put it in exact form. Currently, they both have base, log base 3, but this is a factor or a multiple of log base 3 of x. So the first thing you're going to need is to rewrite. So this one, everything looks nice. Log base 3 of 4 equals, because this is a multiple of log base 3 of x, you will need to rewrite it as an exponential. Okay. Now, according to this review up here, see this right here? You have a log base a on the right, log base a on the left, only one of each. You can drop it according to this review. If you drop it, you end with 4 equals x squared. Okay. Now you're going to need to solve for x. So normally, we are going to take the square roots to both sides. X is going to come out to be plus or minus 2. The question is, can I keep both? Okay. So this side, there's no variables. I don't have to test anything over here, but over here, can I have negative 2 in this location? So the question to us is, can I have negative 2 here? Can the domain of log be negative ever? The answer is no. So x can only be positive 2. So always go back to the original equation and make sure you check your solutions if you happen to have multiple solutions, okay? All right. Again, it's a solve by hand in exact form and decimal. This one, there's no decimal to be found, so that's the end, okay? Now, how would I check that by using the calculator? That it's going to be easy. Well, first, I'm going to clear out what I have already. I have two, in essence, two sides. One equation, but two sides. So I can break it up. I can put the left-hand side on y sub 1. So here we go. Log, I have an old calculator here. It's not gonna, I don't have a change of base. If you look at this, I don't have a change of base here in my math button. So I'm just gonna have to do the change of base of 10, okay? So y equals log, here's a button, log of 4, close it, divided by log of 3. So what I am doing is I'm entering the left-hand side on y subscript 1. I'm entering the right-hand side 2 times, okay, again, change of base, log of x, close it, divided by log of 3. And then I need to close it twice, okay? So this 2 is being multiplied to both the numerator and the denominator, so make sure you're cautious with that. So in essence, I'm breaking up one equation to two equations, okay? Window, let's try the standard one, negative 10 to 10. Oops, my scaling for x, I lie. This is negative 10, this is 10, okay? And hit graph. So the first one that's coming out is the first piece. And the second one is the second piece. So the first one, the flat line, is this left-hand side. And that is to be expected. It's a constant. Log base 3 of 4 is nothing but a constant. This one, there's a curvature. This is a log. So that way this is increasing because you have a base 3. Now, how do I find my answer is where they both intersect. Okay, so second trace, intersect. First curve, it's constant. Very good. Second curve is now jumping to, which you can't see. Where is my, there you go. Second curve is now on the log function. Curvature, enter. Guess it. And the only value that we are coming up with is 2, which is what we have. Now this value right here, y equals 1.26, if I enter in this log, that's what it's supposed to be. Okay, so this y value is nothing but the value, this constant value, log base 3 of 4. Okay, all right. Let's do B. Well, before I do B, let's give you a joke. How about that? Okay, what is a boxer's favorite drink? What is a boxer's, you know, the guy that's punching people, favorite drink? Punch. He loves punch because he loves to punch people. Okay, you got it? Sorry, that's kind of lame. With that said, before we do anything here, before we solve, we have two logs. When you have multiple logs, it's a great idea to rewrite it as a single log. The bases are exactly the same. We are adding, so therefore this is going to become multiplying of log. So log base 2 of x plus 2 times 1 minus x. And I'm going to put a bigger parentheses or bracket around, okay, equals 1. And I have to solve it by hand first because I need it in exact form. There's no log over here, so guys, I can't drop the log base 2. The only way I can solve it now is to rewrite it as an exponential form. Base is 2, 2 to the 1, 2 to the 1 equals x plus 2 times 1 minus x, okay. Well, 2 to the 1 is just simply 2, okay. X times 1 is x. X times negative x is going to be negative x squared. 2 times 1 is positive 2. 2 times negative x is negative 2x. Okay? I'm going to write this in order because that looks awful. Okay, negative x squared in the front. Negative 2x and a positive x is going to give me a negative x. And then bring down my 2. I'm going to subtract 2 to both sides. Okay, I have a positive 2 here and a positive 2 here. I'm going to drop it because even if I subtract it, it will give me a 0. So 0 equals negative x squared minus x. Keep in mind I'm solving for x. So naturally, the next step is to factor out the greatest common factor. In this case, they both have negative x in common. Then I'm going to have a positive x left. Then I'm going to have a positive and minus 1. This would be a positive 1. We have two factors. It is equal to 0. Take each factor and set it equals to 0. Okay. Then this is going to be 0, and this is going to be negative 1. And again, don't be rushed to box it. You're going to need to check your solutions. So here we go. 1x is 0. 0 plus 2. Is this domain positive? Awesome. 1 minus 0. Is this domain positive? Is this domain positive? Awesome. We're good. We can keep it, right? So box that up. X minus 1. X equals to negative 1. Negative 1 plus 2. Is this positive? Perfect. 1 minus negative 1. That gives me a negative 2. Therefore, this is, we can keep, right? So 1 minus a negative 1. I don't know what I said, but I hope I said positive 2. Okay, so I can keep both. Now, that's the exact form. I don't need to do decimal because it came out to be perfect answers. Okay, so it says verify your results using a graphing calculator. Let's check it out. Similarly, on the left-hand side, you have one equation, okay? On the left-hand side, I'm going to punch this whole thing in. Okay, here we go. Log base 2 of x plus 2. So I'm going to go y equals, oops, I'm going to do y equals log, okay, of x plus 2. I'm using change of base. Okay, divided by log of 2. Log of 2. All right, so that's just this first piece. What I'm going to do, though, I'm going to add a set of parentheses at the end here and at the beginning, second insert, to represent that is one chunk, okay? Plus, open parentheses, I'm going to write this second chunk here. So that's going to be log of 1 minus x, close it. So that's just the top, divided by log of 2, because that's your base, log of 2, close it. And I'm going to close it again because I had a set of parentheses to start with. Okay, so that's the left-hand side. The right-hand side, I have 1. Okay, so look at my window. I'm just going to use a standard window for now because, oops, syntax. Syntax means you type something in wrong. So I must have typed something in wrong. Let's go back to y equals. Do I have too many sets of parentheses? That's really the question. Okay, let's double check. I have quantity of log. There's 1 open parentheses, 2 open parentheses, 3 open parentheses. So I have only 1 close, 2 close, 3 close. Okay, we're good. 1 open, 2 open parentheses. Oh wait, something here is missing. Oh, I have sign. Okay, so that's what's happening. Okay, so this is supposed to be log of 1 minus x. All right, so that was my bad. Okay, there you go. So syntax, I mean, I typed it in wrong. Right, graph. All right, so there's that whole piece right there where the two logs are added together. Notice how it looks like an upside down parabola. Okay, I don't need that much x value and y value. Can you see that? The standard window is really big, so I'm just going to go and make it -5 to +5. I normally start out with a standard window, and then adjust. All right, so there you go. Look at that, nice. Okay, it's still too much y value and x value, so how about just -3 and +3? The reason I want it smaller, just because I want to see it better. Right now, I'm blind, I can't see. All right, so there. Okay, so that first curve is the left-hand side. Then you have the constant of 1. See that right there is right at 1. Notice how many times do they intersect? They intersect 2 locations. That means you have 2 different answers. Let's trace them both. So second trace. The first one is, first you have to go to intersect, okay? I'm going to trace the left intersection point. So first curve, second curve, enter. It's giving me a value of -6.36 e to the -13. This means is a scientific notation of negative 6.36 times 10 to the negative 13. That means you move 13 spots to the left of this value. That mean is super, super duper close to 0. So that's why this is okay. And look, the output is 1. Okay. Next, second trace, intersect. And I want to trace the second location, which I want to get closer to it. Okay, so first curve on the parabola, second curve on the constant, enter. All right, check it out. X is negative 1, so my answers are perfect. Okay, and that's normally how you would check on any calculator. Okay, so if I'm going too fast, make sure you need to stop and write it down. Okay, and we're still solving. So here we go. 3 to the x equals 7. We're solving by hand first, then decimal. The only way I can solve for an exponent is hit it with a log. So here we go. Log base 3 of 7 equals x. Okay. Then that means x is log base 7 divided by log of 7, not base 7, log of 7 divided by log of 3. So you can leave your exact answer that way. You can't go any more. But it says also round it to, I believe, let's see how many decimal places. 3. So that's why I kind of use the change of base right away, because I'm just going to punch it in. Log of 7. Oops, not answer 7. Log of 7 divided by log of 3. Close. It's 1.771. Now, can I use ln? ln of 7 divided by ln of 3. Would that be the same? Yes, you can change any base you want as long as the bases are the same. So, x is equivalent to 1.771. You need both if it's not an exact answer. Okay, so this one. Similarly, the exponent right here is where the variable is. So I'm going to hit it with a log. Before I hit it with a log, I'm going to need to isolate this all by itself. So now I'm going to divide both sides by 5. Oh, by the way, I'm not checking on the calculator anymore because by now you should know how to do it, okay? So now we have 2 to the x equals 3 divided by 5. Now that this is all isolated, I will hit it with a log. So log base 2 over 3 divided by 5 equals x. Okay. So because this is division, I can definitely leave it as is. Okay. Or some of you might get fancy and say, hey, you know what? X equals log base 2. Because it's dividing, I can separate that into a subtraction of 2 logs. Oops, base 2. Okay, of 5. So either answer I will totally accept. Okay? There you go. Now I'm gonna need to use my calculator because that's the exact, but it wants you to round. So I'm probably gonna do this one because that looks a lot less work to punch in. So I'm gonna do log of 3 divided by 5. Okay, so that's the numerator divided by my log of base, which is base 2. And I should have a nice negative. Okay, so approximation, 3 decimal places, negative 0.737. Okay, and if you punch that in, you should also get the same answer. Okay, so if you look at these, we have 2 more, which I'm going to stop right here because these 2 are a lot more difficult to solve. So I'm not going to do it over the videos. But hopefully, if you struggle through those first 4 problems, please rewind and repeat. All right, have a wonderful day, and I will see you guys in class.